Good morning, everyone. So today, I think started on app also. So good morning, Vardhan, Tanuj, Aruna. Good morning, those who are watching on the YouTube as well as app. Bharti, Pranita, Vardhan, Aishwarya, Mukshika, Pranita. So how are you all? Teja, Satya. So today we are having one extra class only. So we'll try to finish up. We'll study slowly. We were in the middle of that Lewis dot structure. So we have kept this class so that we can wind up that topic. So that whatever questions you want to do, you can do it on your own. Okay? Means you will not be trapped anywhere. Joined for NEET test series. Done. Okay. So in the last class, I think we have written some questions we have given for homework and some diagrams, Lewis dot structures we have also made. We said ki two methods are there. We have written some rules in the last class. We will see what is the next chapter after bonding. So see, we have two things. One thing we have written before that we were doing like this, na? Ki 6 electrons are there. 6 malo Zn and F4 is there. So we have done 8 electrons, 8 minus 4, 4 electron left, 2 lone pair. Then we were writing AB4L2. This method is very good for finding hybridization, lone pair on central atom, telling shape. This method is very good. This method is very good for telling these things. Steric number, hybridization, shape, lone pair on the central atom. These things we can tell. But from this method, it is very difficult to tell total bonds. Total bonds very difficult to tell. Total bonds very difficult to tell. Total lone pairs. Total lone pairs means what? Central atom as well as terminal atom. So it is difficult to tell from this method because you are not drawing the structure completely. But the last class we have written some rules. Based on that rule, we write the structure. We show all the electrons on the central atom, electrons on the terminal atom, total bonds we show. Like this we are doing. So this method which we have done, that is more extensive. And from that we can tell everything. We can tell lone pair on the central atom also, hybridization also, shape also, all things we can tell. This method you can say like universal method. But it can be a bit time taking. It can be a bit time taking. So if you are knowing the structures already, then you can draw quickly anyhow. But if you don't know the structures, then it's better to follow the rules and draw slowly. If you have to simply find a lone pair, shape, hybridization, then you can do this shortcut, just find the formula. Because in this case, only sigma bond is required. Only sigma bonds are required for telling shape, lone pair on central atom, hybridization, steric number. Sigma bonds are there, then we can do it. Pi bonds not required. But when they will ask you total bonds, we have to make it by the rules. So let's write those structures. Let's write those structures which we have given you in the class. Let's start from NO2. So 4 structures I will write. Everyone focus here. So first we'll write total valence electron. Everyone tell how many valence electrons are there. Total valence electrons. Everyone should reply now. ठीक है. So total valence electron means we don't only check nitrogen na, 12 plus 5, that will be what, 17. Then we have sent central atom, then connect to the terminal atom by 1 bond. So 4 electrons used, 17 minus 4, that means how many left now? And from here we can see 17 electron coming, that means this is an odd electron species. So 13 electron left. What we do after this, can you tell? What we do after this? Now we will practice around 4 or 5 questions, so you will have a better understanding. Then we will go to the next topic. Formal charge formula also I have told you. Formal charge formula also I have told you, but we have not written the points. So we will see NCERT today and we will copy down the points. Okay? Okay, so now I have to distribute these electrons on the terminal atom to complete its octet. So I will give 6 here, 6 here. Still 1 left, so that 1 electron I will give on the central atom. So central atom is having 1 unpaired electron, 1 odd electron. Done. Okay, now you see how many valence electron of the central atom? 5. 2, 2, 1. 2, 2, 1. Octet not completed. Octet not completed. So we have to complete octet also. Madhav. Remaining to central atom. Correct. Acha, acha, acha. Oh, you are telling the process. Very good. Rahman. So octet not completed. Now you tell me how I will complete octet. How I will try to complete octet of the central atom? By making a pi bond. Very good. So I will remove this electron. I will make a pi bond now. Now 7 electrons done. So you see, there are 2 questions. One question is, tell me valence electron of nitrogen in free state. 5. Tell me valence electron of nitrogen in this compound. Then you have to count all the bonds and the non-bonding electron. So 7 came now. Still octet is incomplete. So again some people will try, sir, I can complete, sir. This electron I will remove and I will make a pi bond here. Now when you will do like this, 9 electrons will be there. Is 9 electron possible for NO2? Bolo, is 9 electron possible for NO2? No. Not possible. 4 bonds cannot, nitrogen can make 4 bonds, not more than 4. It can make 4 bonds, 8 electron. But here 4 bonds plus 1 electron is there, na? So 9 coming. This is the problem. Nitrogen can maximum make 4 bonds. 4 bonds we don't have any problem. 4 bonds plus this electron is there, na? This is the problem. So this structure wrong. So you will have to stop till here only. O, 1 bond here. That's it. 7 electron. Stop. Don't make 1 pi bond this side. The point is this. Okay. Now let's try to make the second diagram. NO2 plus. NO2 plus, again you will say, sir, this time the 16 electron. Total valence electron, how many? 16. We can match from here. And then again you will do, sir, NOO. Correct? Then 4 electrons used, 16 minus 4, 12 left. So 12, you will put 6 here, 6 here. No electron left for central atom. See carefully. Then I will try to complete octet. Everyone see here. Then I will try to complete octet of the central atom. So how I will try to complete octet? Remove 1 electron pair, make 1 pi bond. Now 6 electron done. Can you see it? Now I can make 1 more pi bond. From here also I can make 1 more pi bond. 8 electrons done. That's it. Acha, now when you will find formal charge on this oxygen 0, this oxygen 0. Can you find the formal charge on nitrogen? बताओ, what is the formula for formal charge on nitrogen? Formal charge on nitrogen. So you will say, sir, valence electron in free state 5. Valence electron in free state 5 minus non-bonding electron 0 minus number of bonds 4 plus 1. So whenever nitrogen is having 3 bonds, no charge. When it is having 4 bonds, plus 1. Like oxygen, we have said in the last class. Nitrogen 4 bonds means plus 1. Clear, clear, clear? All okay? Can you make the diagram of NO2 minus? Acha, from now I can tell shape and all those things also. See here. I told you from this method I can tell everything. Lone pair. Everyone see here. Dekho, what questions we can ask. Let's do this. First part we will ask you. Valence electron of nitrogen in NO2. Tell me the answer. Lone pair on central atom. Okay? Then I can ask you total lone pair. Then I can ask you hybridization of central atom. So many questions I can ask you. Then finally I will ask you shape of molecule. Can you write all the answers? Can you write all the answers? Bolo. So everyone see here, I am writing the answers. Valence electron nitrogen in NO2 means you have to count all. You don't have to write a 5 here. 5 is valence electron of nitrogen in free state. In this compound, 4 bonds are there. So 8 electron. No lone pair. Lone pair on central atom, 0. Total lone pair, 2 here, 4. Hybridization of central atom, sigma bond, it is AB2 type of molecule, sp, linear. Clear? Can you write again the same things for NO2 minus also? I am giving you time. Draw the diagram. Draw the diagram and write all these things. Acha, some people are asking, sir, why you have not taken this diagram only? Why you have not taken this diagram only? See, what are the problems with this diagram? First point, nitrogen octet not completed. Everyone listen, nitrogen octet not completed. First point. Second point, if you will check the formal charge now, you will get -1 formal charge here. You will get -1 formal charge here. And then you will get +3 formal charge here. We will tell you after some time कि high formal charge unstable. High formal charge unstable. Formal charge on every atom unstable. Okay, so this diagram rejected. NO2 minus. Everyone try NO2 minus. Total valence electron 5 plus 12 plus 1 18. Now what? Central atom 1 oxygen connected. Okay, and then what? 4 used. 18 minus 4 14 left. 6 electron here, 6 here, 12 done. 2 left for the central atom. Clear? Now next part, I will start forming pi bonds. This nitrogen is having 6 electron now. Dekho, is octet completed now? Yes. So stop here. Don't make pi bonds both sides. Don't make pi bonds both sides. Okay, that's it. So now it's time to find formal charge. So when you will find formal charge, now you will get one formal charge on this oxygen, -1. That's it. We have already said yesterday कि oxygen single bond 3 lone pair -1. Rest case 0 0. Now this you can keep in mind also, okay, whenever you see some negative charge na, and oxygen is there, you can think the oxygen will have single bond and that negative charge is present on it. Like I will give you some examples, don't worry. Okay, let's try to do all these questions for this also. Let's try to do all these questions for this. Batao. So I think first one is correct only. 8 electrons are there. This diagram wrong. Lone pair on central atom. This time it will change. So lone pair on central atom 1. Total lone pair 3, 2, 5, 5 and 1, 6. This will also change. This time it is Ab2L. It is not Ab2. Central atom is having 2 sigma bond and 1 lone pair. So sp2. Electron pair geometry should be trigonal planar, but it is bent. It is bent. Clear? So these things we can tell. Correct to everyone? देखो, Ab2 written means 2 sigma bond confirm. 2 sigma bond. 2 sigma bond. But total bonds you cannot tell from here. Total bonds, they can ask you total bonds. Total bonds 3. Total bond pairs they will say. Bond pair of electrons 3. Sigma plus pi 2 plus 1 3. Okay, na? So from Ab2L, like this general formula, we get only sigma bond. So that's why we have to know this method. Okay, let's go and solve a sulfate diagram. Now see, after so much understanding, we don't have to follow every rules. We can now think on our own also. How we can think? See here, sulfur is there. Okay, sulfur is there, 2 negative charges there. So you can think like this, 2 negative is there, 4 oxygen are there. That means this 2 negative charge will be present on 1 oxygen. 2 oxygen will have single bond. Dekho, 2 oxygen will have single bond and rest oxygen will have double bond. That's it. Double bond means normal, 2 lone pairs. Single bond negative charge means 1 extra electron. That's it. So now what is the hybridization of sulfur? Hybridization of sulfur is sp3, because this is Ab4 type of molecule. Shape tetrahedral. Can you tell me NO3 minus diagram? They will ask you number of bond pair of electron and lone pair on central atom. Fine. Bolo, tell me the answer for this question. You can tell hybridization shape also. Hybridization and shape. Do this on your own. Do this on your own. Chalo, 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 chalo. Try. Try to do this on your own. Take time. Whichever method you want to apply, you apply. For hybridization and shape, so we can do by shortcut also. Lone pair on central atom, that also I can tell very quickly. But total bonds, for telling total bonds, you will have to use your brains. For total bonds, you have to use your brains. Let's see who are able to do. Write the answer. Okay, so I am doing by both methods. Everyone see here, I am doing by both methods. Method 1. Method 1, shortcut method I am telling you. Shortcut. So first I can write AB3. Directly I will write AB3 because 3 atoms connected. Okay. Now what is my target? My target is to find lone pair on central atom. You will do like this, ki sir 5 plus 1, 6. And oxygen you share 2 electron, 2 electron, 2 electron. So 6 gone, 0. No lone pair on the central atom. Steric number 3, sp2 trigonal planar. I know this much only. So 2-3 things done. Hybridization done, sp2 hybridization done, shape of the molecule done, lone pair on the central atom done. But total bond pair I don't know. 3 sigma bonds are there, but total bond pair I don't know. Some people may say, ki sir, you have said na ki nitrogen will make 2-2 bonds with everyone. Arre, this is just for saying. To find these things, we are just saying. If you will make like this 2-2-2, then to bhai blunder. Huh? Nitrogen you will make 6 bonds. No, na? So what we are saying here, it is not compulsory, we will do also. So this is the first method. Okay? Although we got everything, only the bond pair of electron of the central atom we are not getting. So from here you can think also, ki sir, I will modify this diagram and all those things. You can try. But by method 2 also we can do all these things. Chalo method 2 dekh lo. Method 2 how we will do? First we will find total valence electron. Total valence electron, how many I am getting 5 plus 18 plus 1, 9. That is 24. 24, 22. Arre bhai, calculation to you do nicely. 22 electrons. Now what? Central atom connected to every oxygen. How many gone? 22 minus 6. What left now? 16 electron left. Batao, what is mistake here? You will say, sir, how you have written this 16? This 16 is not looking correct, sir. Some mistake you have done. Correct. Bhaiya, 3 nitrogen are there. So 6, 3, 18. So you have to be careful. Now it will come what? 24. 24 minus 6. How much it is coming? 18. Correct or not? Now distribute these 18 electrons. So you are knowing, sir, this time I will distribute 666. Lo bhai, nothing left for the central atom. Nothing left for the central atom. Now what? You will remove this electron pair. Double bond. Okay. 8 electrons done. Aipoindi. Now what? You can tell all those things. You can find formal charges also. These are -1 here, -1 here, +1 here. -1, +1. And then you can tell a few points. Like total bonds. Total bonds, 4. Total lone pair also you can find. Total lone pair. देखो भाई total lone pair C 3 3 6 6 2 8. Lone pair on central atom 0. Molecule looks like AB3. AB3 means sp2, trigonal planar. So did you get the difference between both the methods? Is it clear to everyone? So this is the last question which we are doing. Okay. After this, you can do this question on your own. N3 minus. N3 minus you can try on your own. You will get structure like this. SP linear. Some I am writing, you try on your own, like O2F2. This I have told in the next class, I think, na? Ki xenon is there. This I have told in the last class. You can try xenon O3 and so on. I3 minus I have told you in the last class, total lone pair on the central atom. Okay, so let's write the points of formal charge. Let's write the points of formal charge. But before writing all these points, we will see these points in NCERT. We will see these points in NCERT, then we will write. Without seeing NCERT, we will not do anything. NCERT we will have to see where what is written. Where what is written. All the hybridization points we have explained. All these things we have done. Okay? Chalo aa jao. So let's see the points. Formal charge. This is the section. So everyone see here. Everyone read the first point. Ki in general, Lewis dot structure in general do not represent actual shape. We are knowing. That's why to bhaiya for shape we have brought Vesper theory. That's why to for shape we have brought what? Vesper theory. So Lewis dot structure does not about the shape of a molecule. Done. Second point also I have told you. Ki if any ion is there, if any ion is there, then the net charge is possessed by the whole molecule. Like suppose here we have polyatomic ion. मान लो carbonate is there, CO3 2 minus. It is not visible. CO3 2 minus. Then this negative charge is on the whole molecule. In case of polyatomic ion, the net charge is possessed by the ion as a whole and not by a particular atom. It is not like this ki two negative charges on one atom. Later on we have drawn diagram also. Ki whole molecule is -2 and when you will draw you will find ki one negative charge is present on every oxygen atom. One negative charge is present on every oxygen atom. So this line also clear. So see, we are seeing all the lines of NCERT. These lines I can ask you in the paper. Statement 1, statement 2. And finally, we are writing finally. Therefore, it is written, it is however feasible to assign formal charge on each atom. Bhai, I have assigned already. I have told you also already. So finally, the question is, what is the definition of formal charge? What is the definition of formal charge? See here, what is the definition of formal charge? Okay? They are writing here, it is defined as the difference in electron. Difference between, everyone see the definition here? Difference between the number of valence electron of that atom in isolated free state. This is the valence electron in the free state. And what? Number of electrons assigned to that atom. Assigned to that atom means what? It contains bonding as well as non-bonding electrons. bonding electron plus non-bonding electrons. Okay? Which we have written later on. Assigned. Now see, bonding electrons means what? Everyone see here. When you are seeing a bond, like this bond is there, one electron belongs to this oxygen, one electron belongs to this oxygen. So assigned electrons are these. These are assigned electrons. Means non-bonding electron plus half of the bonding. Half of the bonding are assigned to him. Like here we have total 7. So if I have to find formal charge now, I will find formal charge like this. Everyone see. 6 is the valence electron in the free state, minus 7 are the assigned electrons. So the net charge is -1. Net charge is -1. Assigned half. This includes non-bonding electrons also and half of the bonding electron. So see that definition. What is the definition? Definition is it is a difference of. It is the difference of valence electron of the central atom in free state 6 minus difference. What is assigned to it? Assigned to it means all the non-bonding electrons and half of the bonding electrons. That is assigned to it. Okay? After sharing it will get this electron, no problem. But this oxygen, how many electrons are there? 6 plus 1, 7. 7 assigned to him. Okay? Okay. So let's move. So see here. This part is the assigned electron. This part is the assigned electron. This is valence electron. This is the assigned electron. Lone pairs and half of the bonding. Clear? Okay. Next point. Next point, now we have to write these points here. In this paragraph, now so many points are there. So we are going to write these points only in the note section. These points only in the note section. These points of NCERT we are interested. So what are in these points? Everyone see. And now we will write. Note. Visible? Low. Okay. So first point they are saying ki formal charge does not represent actual charge separation, real charge separation. So they will ask you, are formal charges real charges? You will say no. Formal charge is not real charge separation, not real charge separation between the atoms within the molecule. It is not real charge separation. It is not real charge within the molecule. What it shows, it only tracks valence electron. It only tracks valence electron. Like someone is having O minus, like this nitrogen is having O minus. It means what you know? It means it is having one valence electron extra. It means it is having one valence electron extra. Like I will show you, see here. Generally nitrogen having how many valence electron? 5. Generally nitrogen having how many valence electron? 5. But I will see, there is a negative charge. Means one valence electron is extra here. So I will write here like this, 6. So this tracking is done by the formal charge. Sir, for xenon O2F2 oxygen gets bonding with xenon and fluorine with sigma bond each. Fluorine sigma bond and oxygen double bond. Nah? And we have told you that double bonds are kept on equatorial position. Lone pair and double bonds are kept on equatorial position. Clear? Okay. Now let's go to the second point. Second point, we have already said कि formal charge is not good. Zero formal charge best. Formal charge more, that means unstable. More, or you can say less formal charge. Less formal charge. चल formal charge full लिख देते हैं. Less formal charge. Less formal charge means what? Zero. Less means we say what? Zero, not minus. Sir, -2 is there, sir. It is very less. Array, -2, bhai, we don't want. We want zero. Less formal charge means zero. Tending towards zero. Tending to zero. Zero means less charge. -2, very high. So less formal charge, that means what you can say? Batao. Less stable or more stable? Less formal charge means less stable or more stable? Less formal charge means more stable or less stable? You can say less energy, more stable. Correct? And then the last point. Last point they are writing here. Dekho, I have completed this one. Generally, the lowest energy structure is the one which is having least formal charge. Now we are saying that this formal charge is based on this concept that we are assuming pure covalent view of bonding. Means we are assuming pure covalent bond. Okay, na? So formal charge is a factor based on pure covalent view of the bonding. So you can say like this, कि formal charge is based on pure covalent bond. Based on the concept of pure covalent bond. They will write in the paper that it is based on pure ionic nature. No, pure covalent bond. Clear to everyone, I think now? Bolo bhaiya, done. Formal charge over. Lewis dot structure over. Now we will move towards the next topic. That is resonance. Also we can start with coordinate bond also. Both we can do. So let's see. Let's start with the coordinate bond. We'll finish this, then we will do resonance. Coordinate bond. First only I want to make this clear. Coordinate bond is just optional. If they don't ask you, don't use it. If they ask the question, then only think about coordinate bond. Again, I am telling you, total formal charge we don't have. Formal charge we are finding for each atom. Chaitanya. Formal charge, the whole charge which you are seeing on the top, that is for the whole molecule. Formal charge we are finding for every atom. Okay? Good. Surendra. Okay, now see here, again I am telling there can be only one type of questions. They will say, ki, which of the following molecule is having coordinate bond? So you have to just do these type of questions. First you have to know what is a coordinate bond. See, normal, this is a covalent bond only. First you think this also, this is a type of covalent bond. That means sharing, not complete transfer. Normal covalent bond, how it is formed? It is formed by equal sharing. This is what? Equal sharing. Normal covalent bond. Okay? But now what is happening? Suppose B atom is there. Both wants to form bond also. But B is saying, ki, bhai, I will not share any electron. I don't have. I am having, then also I will not share. But I want to make bond. You tell how. Then what will happen? This is like charity work going on. When there is equal sharing, both are benefited. Like A is having 1 electron. After sharing, it becomes 2. B is having 1 electron. After sharing, it becomes 2. Both are happy. Mutual sharing, equal sharing. But in this, B was almost having, suppose nothing. A is having 2 electrons. Now it will share both the electrons with B. So B is in total benefit. B is now having 2 electrons. But A, there is no benefit. A was initially having 2 electrons. Now also it is having 2 electrons. Charity work going on. Both electrons are shared by. So this is coordinate bond. This is sharing only. This is normal covalent bond. Here we have unequal sharing. They will ask you, by unequal sharing, which bond is formed? Coordinate bond. Sharing, not transfer. Keep this in mind. So you can say like this, ki this bond is formed. Achha, coordinate bond is also known as dative bond. You can say ki this bond is formed. This bond is formed. How this bond is formed, bhaiya? This bond is formed when both the electrons are shared by. Both the electrons are shared by. Bolo, what I should write here? You tell. Both the electrons are shared by. Both the electrons are shared by single atom. Both the electrons are shared by single atom. One atom is sharing both the electron. Clear? Theory part over. Okay, what is coordinate bond? Now we will just tell you where coordinate bond can be present. Again, I am telling you that this coordinate bond is totally optional. When they ask you, then only tell it. While finding formal charge and all, don't make coordinate bond structure. Coordinate bond we have to only do when they ask. If they are asking other thing, questions, tell me the lone pair, tell me the hybridization, tell me the shape, tell me the formal charge, make normal Lewis dot structure. Don't make these things. Clear? Is this point clear to everyone? If they ask any question like hybridization, shape, lone pair on central atom, or they ask you formal charge on the atoms, don't use this structure. Clear to everyone? Am I clear? Crystal clear? When they ask where we have coordinate bond, that time only you have to do this. So we are generating 3 cases. Case 1. We are generating 3 cases where we can replace a normal bond by a coordinate bond. First case is, suppose you are having a diagram like this in Lewis dot structure. Suppose in Lewis dot structure you have made a diagram like this, structure like this, the bond is there and plus minus is there. So in place of this, you can write a coordinate bond. In place of this, you can write a coordinate bond. This can be also written like this. You can think कि A is sharing a pair of electron with B. Where negative charge, that is getting. Where positive charge, that is giving, sharing. Okay? Plus to minus. Plus to minus. Okay? Now, next point. We will simply take examples. Can you tell me in Lewis dot structure where we have these condition? Ki there is a bond and there is plus minus. Where we have this type of condition? Can you tell me, suggest me some example? In Lewis dot structure, there is a bond and there is plus minus. Where we have this? Can you suggest me some examples? So first example, and NCERT examples will follow. Ozone. When you have drawn the diagram of ozone, ozone diagram is like this. Here minus. So plus minus bond. So this can be written as this. This can be written like this. Okay. Second example, CO, carbon monoxide. When you will draw the diagram of carbon monoxide, you will get like this. Okay? So bond plus minus can be replaced by a coordinate bond. That's it. NaCl is an ionic compound. This all we have to do in what? Covalent. This we have to do in what? Covalent. Very good. People have written, sir, third one also, NO3 minus. Very good. Like this you have drawn the diagram. Single bond, minus charge, 3 lone pairs. Here we have plus charge. So any one bond, this bond or this bond, can be replaced by a coordinate bond. Any one bond, plus minus, any one bond. Chalo, I am replacing this one. Dekho. Acha, NO2 diagram we have drawn. Have you seen that diagram? NO2 diagram, we can also write formal charge here. See, we have not written at that time, but when you will calculate, you will get -1 here and you will get it +1 here. Formal charge of nitrogen, you will get here +1. How? They go 5 minus non-bonding electron minus bond +1. So 4-5 examples are there. I am telling you all those examples. Generally, questions should come from here only. NO2 diagram. Here plus, here minus. So it can be also written as this. NO2. How many examples done? 1, 2, 3, 4. Bolo, any other example you can remind? Bolo, any other example? Now N2O5 and all are there, no problem. You can think in the same way. N2O4, N2O5, you can think in the same way. Just देखो, N2O4 is there. So we have told कि N2O4 is what? Dimer of this, na? N2O4 is what? Dimer of NO2 only. Connect both. This is N2O4. You can make N2O5 also. Middle one oxygen will come. But these examples I'm not giving you because generally not asked. Okay? HNO3. You can do the same thing. Nitrate ion. Nitrate ion I have made. See how you have made nitrate. Like this only you can make HNO3 also. N double bond O. O coordinate bond. And O minus you connect here H. OH. This is only diagram of HNO3. Na? NO3 minus done. That means HNO3 also done. In place of O minus you will write OH. Clear? Tell me those examples which we have done in class. So all these examples are based on this point only, plus minus bond. You can also keep one thing in mind. Ki coordinate bond, it is not necessary, it is always a sigma bond. Coordinate bond can be a sigma or pi bond. Sometimes it is like a pi bond also. Sometimes it is like a pi bond also. Like this CO diagram, you can say this is like a pi bond. You can think in this way. This is like a pi bond. Now only we are writing notes. By notes, we will share a screenshot, na? That QR code. At that time also you can write the notes. Now try to understand the things. देख लो. Everyone see all these diagrams once. Take 1 minute time. See these diagrams. Suggest any other compound which you have seen very frequently. बताओ, ठीक है। F part in 205 also you can write, no problem, ठीक है। So case 1 over, N3 minus, N3 minus also plus minus is there, correct, you are saying correct, N3 minus, okay। चलो next go to the second case. Second case is more important than first one also. Second case is more important than first one also, you can think. That's why I'm telling you here. You can think like this, if any atom makes bond more than its normal capacity, more than its normal capacity, then it is a coordinate bond. Then it is a coordinate bond. How you can say? Have you seen ammonium diagram? Ammonium. You will say, yes sir, ammonium diagram we have made like this. Lewis dot structure of ammonium ion we have made like this, correct? You can also imagine, you can also think like this. You can also think like this. Ki ammonia is there having lone pair. Acha, more than its capacity means what? Like nitrogen generally form 3 bonds. Nitrogen generally forms 3 bonds. But मान लो sometime it forms 4 bond. Then the 4th bond is a coordinate bond. Oxygen generally forms 2 bonds. But मान लो sometimes it is forming 3 bonds. So that the 3rd bond is what? Coordinate bond. Phosphorus forms 3 bonds, 5 bonds. But मान लो sometimes it is making 6th bond. That is a coordinate bond. Okay? So like this we are talking. Boron, it forms 3 bonds. But sometimes there are 4 bonds also connected to it. So that 4th bond can be a coordinate bond. So now what will happen? You can also think ki H plus came near him. You can also think ki H plus came near him. Now H plus is what? Nothing is there. There is no electron with H plus. But it wants to form bond. Ki, sir, I want to form bond, sir. Where is your electron, sir? I don't have any electron, sir. But I want to form bond. Huh? This is like this only, sir, I don't want to study, sir. But I want to become doctor, sir. Difficult. ठीक है ना? But here we have option. What option is there? H plus will come to him saying, sir, please, please, please. Then this ammonia will share a pair of electron with H plus. And it will become what? Ammonium ion. These electrons are counted in nitrogen also. Now these electrons are counted for hydrogen also. Coordinate bond form. Similarly, you can think about hydronium ion. Generally, we make hydronium ion like this. Achha, now to you are knowing, sir, now to we are knowing Vesper theory, sir. So you can make diagram in accordance with Vesper theory. ठीक है, good. But you can also imagine like this, कि first water was there, relax, 2 sigma bonds, 2 lone pair. Now again H plus came to him. Arey, I want to form bond, please. So it will share a pair of electron with H plus. They will ask you in hydronium ion, who is sharing a electron with H plus? Option will be water. Next option will be oxygen gas. What you will tick? Water or oxygen gas? Water or oxygen gas? Oxygen gas means O2. You have to tick what? Water. Similarly, there is a third example. In bonding chapter only, there is a question like this. They will mention like this. कि NH3 they will write, ऐसे लिखेगा. NH3 they will write, dot they will write, and BF3 they will write. What is this? What is the meaning of this? NH3 dot BF3. Everyone see all these examples? Correct. So this means that there is a bonding only. We know that BF3 is having 3 bonds only, 6 electrons, but it has a vacant p orbital. So what happens? BF3 is there, NS3 is there, NS3 shares a pair of electron with BF3. NS3 shares a pair of electron with BF3. So example can be like this. Next example, you can think PCl6 minus. You think if PCl5 is there and Cl minus is there. Cl minus sharing one electron pair with PCl5. BF4 minus also you can think like this. Ki BF3 is there, F minus came to him, share a pair of electron. So these two examples are most important. After that, you can focus on these things also. So like if we will try to give example, there are so many examples. But with time, you will come to know slowly, gradually, dhire, dhire, dhire. Clear? So these are the examples. Everyone see all these examples nicely. I told you, I think, diagram of Al2Cl6. Do you remember? I told you the diagram of Al2Cl6. We said ki AlCl3, AlCl3, AlCl3 in complete octet, it will form dimer. AlCl4 minus also. Normally oxygen form 2 bonds, but here it is forming 3 bonds. So the third bond is what? Coordinate bond. Clear? Al2Cl6. We have told. Dimer बताया था कि Al is there, Cl, Cl, Cl. Al is there, Cl, Cl, Cl. Now they want to form dimer. How dimer is formed? Here one lone pair. It will share a pair of electron. Here so many lone pair. It will share a pair of electron. Coordinate bond. तो चलो लो बता दिया. Al2Cl6. Al2Cl6. Cl is having so many electrons here. So it share a pair of electron by coordinate bond and dimer is formed. Al2Cl6. Octet completed. 8 electrons. Now this is sp3. Now this is what? sp3. Clear to everyone? Acha, one more point you keep in mind. Hybridization of cation in PCl5 solid. There is a question in gym material like this. PCl5 solid. Solid they will write. This is important. This is written in P block. Whenever solid written, it exists in ionic form. It exists like PCl4 plus and PCl6 minus. So the cation part is sp3 hybridized, anion part is sp3d2, octahedral, tetrahedral. So you see they are asking about cation or anion. PCl5 solid. PCl5 solid. PCl5 solid. If they don't write anything, then you assume PCl5 5 bonds sp3d. But if they write PCl5 solid, then you have to think like PCl4 plus PCl6 minus. Is it okay? Okay. Let's go to the third and the last case. Now they see this third and the last case is it is like forcefully telling something. Forcefully bringing the coordinate bond. Forcefully, so least important, but questions are there. I told you that only one question is there in this coordinate section, which has coordinate bond. Which of the following compound have coordinate bond? Okay? So that you have to do. In this case, what is happening? If you are having a double bond B, then this whole 2 bonds can be replaced by a coordinate bond. Whole 2 bonds can be replaced by a coordinate bond. You think like this. Before this, it was sharing 2 electron, 2 electron, 4 bonds. A was getting benefit. A was having 2 electrons, by sharing it becomes 4. B is having 2 electrons, by sharing it becomes 4. But A is having here 2 electrons, it can share by a coordinate bond also. So this is also one possibility. Yes, SO3 and all. So, but in this case, what you have to keep in mind, this is generally a third period element having a super octet, complete octet, you can say. Complete octet should be there, not less than that. Complete octet. Complete octet. And it will give to the other one. This is generally second period element. Generally. Like I will show you example. Main example is SO3. Now everyone knows कि sir SO3 diagram so I am knowing. This sulfur is expanded octet. 12 electrons are there. Super octet. Rich, rich, rich. Okay. This is the last case. Okay. Then in the next class we will start with resonance. We will complete resonance and we will move to bond order section. We'll complete resonance and we will move to bond order section. Clear? Okay, everyone see all the examples? Clear? Okay, so how this SO3 is formed? You can think like this, sulfur was having 6 electrons. It shared all the 6 electrons. 6 becomes 12. 6 becomes what? 12. If they ask number of bond pair in SO3, it is 6 or 5. Now Vardhan, that's why I said in beginning, whenever they ask you any question, you have to think about Lewis dot structure. You don't have to do question based on coordinate. Only question if they ask you how many coordinate bonds are there, then you tell. Who is having coordinate bond, then you use. If they don't say coordinate bond, don't use it. Okay, so how many are there? 6 bonds, that's it. 12 electrons, that's it. For any question, don't use coordinate bond. Do by Lewis dot structure. Now sulfur was having 6 electron. It shared 6 electron. It became 12. Super octet, super rich. So now we can say here one more option was there. When oxygen is making bonds. Sulfur knows sulfur I am super rich by 12 electrons are there. Okay, na? So now sulfur will do some charity work. It will not do equal sharing. Like suppose you are there, I am here, student life, college. You are in student life in the hostel. Now suppose we have to buy one samosa. Then what? You will give it 10 rupees, I will give 10 rupees, 20 samosa came. Fine, equal sharing. Both are benefited. In 10 I got also samosa, in 10 you also got samosa. But this is not good. I am teacher. I am in better condition. So what I will do now, I will say, you don't give. Don't worry. I will give both 20 rupees. So this is the mood of sulfur now. Here I am having so many electrons. Let's do the charity work. So the charity work begins. First, it will make 2 bonds by sharing equally. Here also 2 bonds by sharing equally. Now sulfur realizes, my octet to completed. My octet to completed. If I will share this equally, I will become 12. But what is the use? I am already completed octet. Now what? It will do charity. It will share both its electron with the oxygen. Not equal sharing, unequal. Oxygen octet completed, but sulfur is now 10 electrons only, I think. 8 plus 2, 10. But then also no problem. Octet is complete for sulfur. Then sulfur will think, let's do more charity. This time though it is just making these two bonds by sharing electron. And rest two lone pairs, it shares by coordinate bond. So 8 electron. Now also he is not feeling any problem. So they will ask you question ki how many coordinate bond are possible in SO3? What will be your answer? How many coordinate bond possible in SO3? What is your answer? How many coordinate bond possible in SO3? Maximum 2 possible. Coordinate bond. मान लो sulfur, you will say sir sulfur will not give all 3 by sharing coordinate bond. लो बनाओ. When you will do like this, now sulfur is deficient. Bhai, I will do charity that much only na, how much suits me. In this charity work, now sulfur octet is not completed, so not possible. Only you can make 2 coordinate bond. So like this logic you can apply everywhere. Like you have phosphate ion. You are knowing if phosphate ion sir diagram is like this. I know now. Very good. Diagram is like this. We know now. So phosphorus is having 10 electrons, superoctet. So you can also do like this. Ki phosphorus is having 5 electrons. 3 electrons it will share equally. And these 2 electrons it will share by a coordinate bond. So it is having 8 electrons now. That's it. You can apply the same concept in sulfate also. SO42 minus sulfate diagram is like this. Again sulfur is rich, 12 electrons. So it can again make 2 coordinate bonds. 2 lone pairs equal, 2 electrons equal sharing and 2 lone pairs by coordinate bond. Still it does not have any problem. 2 to 4, 4 plus 8. So in these cases, wherever you find sulfur double bond, phosphorus double bond, more than 8 electrons, in those cases you can replace it by a coordinate bond. So this is the third case. Now everyone try to recall and keep everything at one place, whatever we have taught. So we have already said ki coordinate bond, when they will ask you, then only tell. Don't say like this, ki sir sulfur having only 4 bonds. Wrong. We said na, these are just possibilities we are finding. We can also do like this. But all the questions you have to do from Lewis dot structure. All the questions you have to do from Lewis dot structure. Clear? So 3 cases are there. First 2 cases more important. We should focus on this. Okay? I think coordinate bond heading is also not there in NCERT. Have you seen the heading of coordinate bond in NCERT? Have you seen the heading of coordinate bond in NCERT? You will say no. The next topic is resonance. Not there. So that's why means we have done so much. We have given you 3 cases, means so much we have done. Nah? Okay. So the next topic is like resonance. Now see, resonance you have studied in organic chemistry and you study so much. Here in bonding chapter, to just a little bit given. In organic chemistry, so much is there. But they have used this concept in bonding chapter also to explain some molecules. Like CO, carbonate, CO2. So we will study here resonance in a limited amount. And whatever you will study here, you will find here, sir, all these things so we are already knowing. Good then, very good. Like if I ask you what is the resonance, you will say, sir, resonance is a phenomena in which delocalization of, bolo, pi electron or sigma electrons? Sigma electrons or pi electrons? Pi electrons takes place. Delocalization of pi electrons takes place in conjugated system. So now here we are having three words. What three words are there? Now this is light topic for you. Sir, delocalization is there, pi electrons are there, conjugated system is there. So what do you mean by this? Delocalization means what? Electron from its orbital leaves the orbital and goes in some other orbital. This is known as what? Delocalization. Leaves its orbital and goes in other orbital. That is delocalization. Pi electrons, which can make pi bond. Conjugated system, we have told you 5-6 example of conjugated system. Like double single negative. Electron cloud is there, not there, less, more, less, like this. Conjugated, alternate. Conjugated means what? Alternate. Okay, many more examples are there, double single lone pair, double single positive and all. In this bonding chapter, mainly we will use these two only. Double single negative. So this only we will use, double single negative. And we will teach you in such a way that you are not knowing resonance now. Suppose you are not knowing resonance now, then how? How this topic is coming? So we will start from ozone. Again, see, ozone is coming. Ozone structure we are drawing for the third time. Sir, ozone structure to now very easy. Everyone knows it. Came in NEET exam also, sir. Cancelled NEET, where paper got leaked. Rhyming, no? Cancelled NEET, where paper got leaked. Then re-NEET happened. Then everyone's leaked. So good. Chalo, then also we have done good in re-NEET exam. But we can do better. Okay. So this is the diagram. Now what I can ask you? What I can ask you, bhai? Suppose we are not knowing resonance. Now we are knowing resonance. Sir, people will say, sir, see, double single negative conjugation. I will put here this bond here. You are knowing these things. But now I will not teach you in this way. We will say like this. See, you have made double bond. You can also make its structure like this, na? You can also make resonating structure. You can also make its structure like this. Correct or not? Yes. Then we will ask you, if both structures are correct, then which is the double bond is ozone? Left one or right one? Which is the double bond in ozone? Left one or right one? Then if you are knowing resonance, you will say, sir, no one is double bond. Because that pi bond is what? Resonating. This is resonating structure 1. This is resonating structure 2. And you will say, sir, this pi bond is resonating. This both structure does not exist. Then what exists? You will say, sir, actually, ozone is like this. Single bond, confirm. That low pi bond, one pi bond you are seeing, sometimes it is here, sometimes it is here. That is distributed, that is resonating in two positions. Correct or not? That is resonating in both the position. And this is known as, what is this? Can you tell? Bata bhaiya, long term people, what is this? This is resonance hybrid. Molecule exists in form of resonance hybrid. Resonating structure don't exist. ठीक है ना? These things we are knowing. Class 11 students, those who don't know, they will be very surprised. But now we know that resonating structures are not there. In NCERT, they have written the values. This is double bond, so its value should be 121 picometer. This is single bond, so its value should be 148 picometer. Then I will see, this is 148, this is 121, and I'm confused. But when you go in lab, what you find? No one is 121 and no one is 148. This is 128 picometer and this is also 128 picometer, and both bonds are same or different? Same. They will ask you how many types of bond length in ozone? OO bond length. Reply. How many types of OO bond length? We will do this question only, not more. How many types of OO bond length in ozone? Only one type, because both are what? Same. Both are what? Same. So in the next class, I will tell you how to find bond order and average formal charge. We will try to find this. The average formal charge here is -half, and the bond order is 1.5. So this we will tell you in the next class. Bond order is 1.5. But you are knowing also many things. So we will start from here, and then we will go towards bond parameters. So hopefully we will complete most of the syllabus tomorrow only. Tomorrow is your class, normal class. Today was an extra one. We wanted to complete syllabus as soon as possible so that you have sufficient time to revise and do questions. Okay? Because these topics you are knowing a bit. Now you practice. You practice all Vesper theory, hybridization from anywhere. Everywhere you practice. So that's why we have completed today. Okay? So now you are having 3-4 days to practice. Practice all questions of resonance, hybridization, lone pair on central atom, total bond pair, what is the shape, structure, geometry, electron pair geometry. They will say electron pair arrangement. Electron pair arrangement means what? Electron pair geometry. Cumulative exam is also there, na? So that's why now only we'll finish it up. So you have sufficient time. Cumulative exam not done. Chalo, no problem. Chalo, this week only something happened, I think. Monday, space was not there. Chalo, so let's share this ozone and bond order formula. We will again do this in the next class. That one only I'm saying, like space exam, so just this Monday done only. So you revise all these things, read hybridization, read everything, and enough for today. Okay? So now again after 2 weeks, 2 weeks cumulative exams are there. Face will come now. They will show the real faces. Okay? Chalo. App does not support scan. Array, you can scan from Google Pay also. Any scanner you will scan, they will tell you about the page. That page will open. Google Pay also, you can scan these things, no problem. Any scanner you can download and use also. This is simply a link of a page. Okay? So when you will scan it, don't worry, your money will not be transferred. App working by many people are connected on the app also. So check once. So thank you everyone. Bye. Do more and more questions. More question practice required. JEE mains, advanced, whatever you want to do. If you have doubt, you ask. Okay, thank you everyone. Bye.